In this video, we're going to be solving trigonometric equations with coefficients in the argument. So let's start off with question 5. So for this question, we're going to use the fact that sine 2 of theta is going to be equal to 2 sine of theta times cosine of theta. So using this, we can rewrite this as 2 sine of theta cosine of theta plus 2 cosine of theta, and that's going to be equal to 0. Now we can factor out 2 cosine of theta. That's going to be sine of theta plus 1, and this is going to be equal to 0. So now we can set 2 cosine of theta is equal to 0, and we get cosine of theta is equal to 0. And we know this occurs when theta is equal to pi over 2, also when theta is equal to 3 pi over 2. Now we can do the same for sine theta plus 1. That's going to equal to 0. Then you can write that as sine of theta is equal to -1. And this occurs when theta is equal to 3 pi over 2, so 270 degrees. And that was already included. Make a note of that. That's already included, so you only actually state it once. So we're going to put our final answers right here. Pi over 2, 3 pi over 2, and those are our answers. Now let's move on to the next question. So we have 4 sine of theta plus 6 sine squared plus cosine 2 theta. So now we can use again the fact that another identity that cosine 2 of theta is going to be equal to 1 minus 2 sine squared theta. And now we are able to rewrite this as 4 sine theta plus 6 sine squared theta plus 1 minus 2 sine squared theta. That's going to be equal to 0. Now all we have to do is we can just rewrite this again. Okay, as 4 sine theta plus 4 sine squared theta plus 1. And now we can set that equal to 0 because you just cancel that, you just add those together. Now down here, now we're going to do some u substitution. So we're going to say let u equal to sine of theta. And now you're going to replace u with sine of theta in every single location where sine of theta is at. So now we're going to rewrite this as 4u squared plus 4 times u plus 1 is equal to 0. And then this is going to be transferred that over there. That becomes u squared plus 4u plus 4. And that becomes u plus, well, multiplies to 4, but adds up to 4. So that's 2 and 2. U plus 2. Then you have to divide each by 4. So that gives you u plus, so that gives you 2. Oh, okay, so it's 2 or 1. So that's just u plus 2. Oh, sorry. That's just 2u plus 1 and 2u plus 1. Now that is just going to be over here. So now we can just know that u is going to be -1/2. Yeah, so then you know that sine of theta is going to be -1/2 because you have to resub sine of theta back into there. So you have sine of theta is equal to -1/2. So now we have theta is equal to 7 pi over 6 and 11 pi over 6. So now we can box that as our final answers. So now we can move on to question 7. So for the interval of 0 is less than or equal to theta is just less than 2 of pi. We have 0 is going to be less than theta over 2 is less than theta. So sine of theta over 2 is going to be greater than or equal to 0. So this means therefore we have to use the positive half angle. So what that means is that you have sine of theta over 2, and that's going to be equal to 1 minus cosine of theta divided by 2. So that's the formula you're going to use. So you can rewrite this as 1 minus cosine theta plus 1 minus cosine theta over 2, and that's going to be equal to 0. And let's say we're going to let this entire expression be greater than or equal to 0. Basically, we're going to say that. That means that I'll just rewrite this down here. 1 minus cosine theta plus 1 minus cosine theta over 2. That's all going to be greater than, that actually says 1. So then, because we know that, then we know that 1 minus cosine theta is going to be 2 u squared, because we're just going to use, actually, we're just going to do let t equal to what? Let t equal to this. So then you're gonna have this from using, this is gonna be substitution. Okay, it's kind of on the other question, but you know what, it's okay. 2u, okay. So we plug that in right there. So now this 1 minus cosine of theta is equal to 2u squared. So this becomes 2u squared plus u is going to equal to 0. And you're going to have u, you can factor out one of the u's. So that's 2u plus 1, and that's going to equal to 0. So that means u is equal to 0. And also you can set 2u plus 1 is equal to 0, and that means you have 2u is equal to negative 1 divided by 2. That means you have u is equal to negative 1/2, and therefore this is going to be impossible because t has to be greater than 0, and so now you have t is equal to 0, and you can plug this into 1 minus cosine of theta, and you're going to divide that by 2, and then that's going to equal 0. So then cosine of theta is just going to equal to 1. So therefore you have theta is equal to 0. So that's it for number 7. Okay, that took up a lot of space. I'm just gonna move some of our work for this problem over. Okay, let's move on to question 8. So you see for question 8, again, we have to use this identity, the sine of theta over 2. This is going to just equal to 1 minus cosine of theta divided by 2, and that's going to be non-negative. It's going to be positive. So now we can rewrite this as root 3 times 1 minus cosine theta, and we're going to divide this by 2, and this is going to be equal to 1 minus cosine of theta. Now let's use the variable t, and we're going to set this equal to 1 minus cosine of theta. Essentially it's going to set it equal to what is right there, and then now that we set it equal to 1 minus cosine of theta, and we're going to also say that it's going to be greater than 0. So therefore, we have root 3 times t over 2 is going to equal to t. This is also what is right here. So then we can square both sides. So upon squaring both sides, then we have this and then this, and then after that we have t, you have 3 times t over 2 is equal to t squared, and now over here we have t squared is going to, we're going to subtract 3 over 2t, and then we're going to just set it equal to 0, and now we're just going to factor out the t minus 3 over 2 is equal to 0. So now t is either equal to 0 or t is equal to 3 over 2. So t equals 0. Now you plug that in. So you have 1 minus cosine of theta is equal to 0. If cosine of theta is equal to 1. So then you have theta is equal to 1. So now for this, you have cosine of theta is equal to 1 minus 3 over 2. So then this is also this is going to equal 1 negative 1/2. Yeah. So that means cosine of negative theta 1/2. Theta is going to be 2 pi over 3 and 4 pi over 3. So those are going to be your answers, but I'm not going to rewrite it. That's good enough for... Those are our 3 solutions. Oh, yeah. Yeah, those are our 3 solutions. All 3 satisfy the original equation. Oh, up here, our only solution was this for question 7. Now let's move on to question 9. So we're gonna first write cosine theta. Okay, I'm gonna write that as a note. Write cosine theta in terms of sine theta over 2. So what you're gonna do is you have cosine of theta is equal to 1 minus 2 sine squared theta over 2. Now we're gonna let u is equal, or I'll just use s. Let s is equal to sine theta over 2. So now you have 2 plus 3s. That is going to equal to 1 minus 2s squared. And then 0 is equal to 1 minus 2s squared minus 2 minus 3s. And that's going to be negative 2s squared minus 3s minus 1. And now we're going to multiply by negative 1. And let me write the 0 right there. And then this is still going to equal 0. And then, yeah. So you're going to have 2s squared plus 3s plus 1. And then you're just going to factor this. S squared plus 3s plus 2. Now that's going to be what multiplies to 2 but adds up to 3 is just 1. So yeah, you're just going to have that, and then you're going to divide by 2. And then that's going to be 2. Okay, yeah, that's going to be s plus 1. And then 2s plus 1 is equal to 0. Now after this, you're going to have s plus 1 is equal to 0. Now s is going to equal to negative 1, or you're going to have 2s plus 1 is equal to 0. Now you're going to have negative 1 is equal to 2s, and then s is going to equal to negative 1/2. So now we want to ask, but we're on the interval. Here. But you have to note that theta is going to be a subset of 0 to 2 pi. And also that means that, so therefore for theta over 2, that's going to mean that it has to be a subset of 0 to pi theta. And on theta over 0 to pi, we we have sine theta divided by 2 is greater than or equal to 0. So s cannot be negative. So therefore, these are both negative. Therefore, we know that there is no solution in 0 is less than or equal to theta is less than 2 pi that satisfies this trig equation. And this is for that's for question 9, but we kind of ran out of space again. So we kind of ran out of space. So I'm going to try to make room. Wait. Okay. So let's move on to question 10. So for question 10, we're going to start by writing cosine of theta in terms of cosine theta over 2. So we have cosine of theta is equal to 2 cosine squared theta over 2 minus 1. Now we're going to let c equal to cosine theta over 2. So we have 4c is equal to 2c squared minus 1 plus 3. And this is going to equal to 4c squared minus 2 plus 3. And then this is going to equal to 4c squared plus 1. And then you're just going to remove everything onto the one side. So 4c squared minus 4c plus 1 is going to equal to 0. So now we have a quadratic. C is going to be equal to 4 plus or minus negative 4 squared minus 4 times 1. And we're going to divide this by 2 times 4. And then c, okay, this is also going to be, this is not c, this is 0. So that's going to be 4 plus or minus 16 minus 16 divided by 8. That's going to be 4 over 8. And that's also going to be equal to 1/2. So thus cosine theta over 2 is going to equal to 1/2. And also we have 0 is less than or equal to theta less than or equal to 2 pi. Therefore we have 0 is going to be less than or equal to theta over 2 is less than or equal to theta. And in that interval, cosine x equals 1/2 only at x is equal to pi over 3. So therefore theta over 2 is equal to pi over 3. Therefore theta would just be 2 pi over 3. So that's our solution. And that is it for solving trig equations when you have an argument in the when you have a coefficient in the argument.